Hi guys, this is going to be our final assignment for the sound packet. It's the last two pages, 19 and 20. Nothing really new, just another way to do it that's not in a chart. If we have multiple sound levels that we need to add together to see what the overall loudness is. Again, it's not a logarithmic scale, so it's not going to be simply 1 plus 1 equals 2. So again, look back in the chart from page 14, I believe it was, or up in the top here, there's some steps and methods here. I'll go through each one with you. Just follow along. And if there's any questions, please send me a Schoology message or email, and I'll get back to you. So here, number one, we have two fireworks. They're going to go off at the same time. They each have a loudness of 95 decibels, and the overall answer is to combine them both. So just to find the intensity of one firework, we're just converting 95 decibels to watts per meter cubed or squared. Sorry. So again, that's going to be in that exponential or exponent notation. So it's the 95 decibels, but we need to divide that by 10. So technically, you could do quick math and just do 10 to the 9.5. And to get it into that linear scale, we have to compare it to the lowest sound that we can hear, that 10 to the negative 12, and making sure we plug that into our calculator correctly. We should be able to get the answer here, 3.16 times 10 to the negative third watts per meter cubed. Now, what if we have those two intensities? Since we're already in that logarithmic scale, we could just take that answer that we just got and multiply it by 2 to get our answer that's on our packet. That's only because we're already in that linear scale. When we're in a linear scale, we could just do like we normally do math and add or multiply by factors of how many speakers or whatever fireworks we would have in this case. So that's one benefit of going and converting to that other scale. And then C is done for you to go back in to see what the true loudness is in, not true loudness, but loudness in the more common decibels scale. Number 2, we have these two sounds played simultaneously, same time. So the first thing we're going to do is convert each one to the linear scale, which was we're just taking that 10 to the 8.2 or 82 divided by 10 and multiplying it by that lowest intensity to get our answer that's there. And again, if you're not able to get these answers, take a look at your calculators, try it a few times. And if you're getting the same wrong answer, send me a Schoology message and I'll get back to you. Say part B, we now have our 87 we're going to convert. 10 to the 8.7 or 87 over 10, whichever way you prefer, times that 1 times 10 to the negative 12. And we got the value there. Now we have to add them. So since they're already in a linear scale, we can just simply add those two numbers, which being in scientific or exponential notation, making sure that we plug everything in right. Oops. I'm messing up here. There we go. And hopefully we can get that 6.59 times 10 to the negative fourth as our answer. Then going back to decibels, just because that's usually what people are more familiar with, and scales are measured in as far as what is healthy and unhealthy and going to cause damage. This is when we did that other log button like we did in the previous worksheets, because we have our intensity in watts per meter squared. I always want to say cubed. And then just going back the other way. And again, as you do more and more, you'll see the patterns. It is somewhat more of a mathy process. So plugging that all in, we should be able to get about 88 decibels. 3, kind of the same thing. We have 2 rifles being shot at the same time, each 80 decibels. What's the intensity? Taking our time, just mainly for more practice. There are easier ways to go through all in one shot, but I think it's just easier and better practice to go through each conversion. So we see what we're doing. So 10 to the 8, or 80 divided by 10, times our 10 to the negative 12. Then again, that's just for the one, and we just want to know the intensity, just one of the rifles. I'm sorry. So we already have the combined is 80. So this value is both of those rifles shot at the same time. Now we just want to know one. Well, the little clue is if we're in our linear scale, we could just take that 1 times 10 to the negative 4 and divide it by 2, because it's in a linear scale, which our answer is here. And then the last thing, going back to decibels, just to see what we're working with here in that scale. And this being somewhat more of a meticulous math thing, it's really making sure you show your work, or in the situation that we're in now, using your resources, because there will be quizzes coming along in the future and tests, whatever that's going to look like. Because we still have to have a way to give you guys a grade. Okay, so that was number 3. Now I think this is our last one. So we have a party and a bunch of people talking. One person talking 65 decibels. How many people would you have to go to 78? Well, this might be important because in some cities and towns, there are noise ordinances past certain times. So if you have too many people over your house, you could be exceeding that sound intensity, that noise ordinance, and be ticketed or fined. So let's see how many people we can have. So we have the one person, and we have it in decibels. So we need to convert that to our linear scale because we want to see how many people. So it's 65 or 6.5. And we got our answer, hopefully, that's here. And that should be 10 to the negative 6. It's a little bit of a formatting mistake. I don't know what happened when I converted the files. And then when we would exceed that possible maximum of 78 decibels, what would that look like? So 10 to the 7.8, or 7 over 10 times our lowest limit. And we get this. And if we just compare those two to see how many people we would need, since it is a linear scale, -5. We would see that we would want no more than about 19 or 20 people, or that might set off some red flags and get us ticketed and make that little party a little bit more expensive than it cost to throw in the first place with all the food. And the last problem, 5, we have our threshold of hearing, the smallest thing that we can hear. Then we have a jet engine at 138. And just converting that to watts per meter squared. So same thing that we've been doing. What might be kind of interesting to do is divide that by that normal conversation and see how many people it would take to have a normal conversation as loud as a jet. So you could compare those if you really, really wanted to. And we're not going to continue on. Feel free if you like. Past page 20. That's a little bit just more practice if you need. There's a lot of answers already there. As you can see, already typed out, just mainly for more practice. Again, if you have any questions with calculators or any of the solutions, you're not getting the right numbers on your calculator, or what buttons to press when, send me a Schoology message. I'll get it back to you as soon as I can. All right. Have a great day.